This last video is about the work cycle in an engine. We had already looked at how it's possible to do work on a gas by pushing a piston down and compressing that gas. When you do that, you're putting energy into the gas. The diagram below shows an example of this. It's a pressure versus volume diagram. And so here, the gas starts off with a large volume, but it ends up with a small volume. And so the gas is taken from one state to another, where there's a large volume and a small volume. And the gas goes from low pressure to high pressure. This is actually one of the strokes of an engine. The compression stroke, it's called. So what situation does this PV diagram show? Compression of a gas. Keep in mind, it requires work to compress a gas. So in this particular stroke, you're not getting energy out of the gas, you're having to put energy in. But oftentimes an air-fuel mixture needs to be compressed in order to ignite. Notice that each of these processes have the same initial and final states. The area under the curve represents the work. First of all, are these expansions or compressions? These are all examples of a gas being compressed because the volume goes from a high volume down to a small volume. But which one requires the most work? A, B, or C? B requires the most work. Why? Because they're actually compressing the gas when it's in a highly pressurized state. It's more difficult to compress a gas when it's in a highly pressurized state versus a low pressure state. C is in between the two extremes. B requires the most work. A requires the least. In question 1, is the work done by the surroundings on this gas positive, 0, or negative? The surroundings do positive work here. In all A, B, and C diagrams, positive work is being done on the gas. You could think of it as a person physically pushing the piston down. They're applying a force and the gas compresses. So it's positive work that they're doing. Now imagine pulling the plunger up. What kind of work gets done in this case? Does the gas do positive work or negative work on the piston? Well, think about it this way. The gas pushes up on the piston. And the piston physically does go up. Call that the delta X. And that's the force. So, what kind of work does the gas do here? The gas does positive work. On the surroundings. So this is one of the strokes of an engine as well. It's an expansion stroke, sometimes called a power stroke. The gas does work on the piston, which can in turn drive the vehicle. So this is an example of where a gas can do useful work. A cyclic process is what an engine does. It's one which originates and ends in the same state. So on a PV diagram, pressure versus volume diagram, the cycle process will appear as a closed curve. In the case of a gas, it's going to be compressed and then expanded and then compressed and expanded and compressed and expanded over and over again in a cycle. Whenever the gas comes back to the original state that it was in, the change in internal energy for that gas is zero. The gas goes back to the same state it was in originally. However, the net work that's done in the cycle is represented by the area inside the path. That's the work that really gets transmitted to the vehicle. In the case of a heat engine, there's a source of energy at the top. The engine uses that energy to do useful work. And then the excess energy gets expelled to the cold reservoir. The efficiency of the engine will be the useful work output divided by the energy input. And efficiencies are never 100%, always less than 100%. This diagram shows the four processes of an engine's cycle. At first, this gas is placed in contact with a hot reservoir, and an expansion takes place. In the second process, the gas continues to expand while not in contact with that hot reservoir anymore. In the third step of the process, the gas is placed in contact with a cold reservoir and a compression is allowed to take place. In the fourth process, a compression continues while the gas is not in contact with that cold reservoir anymore. This returns the gas to its original state and the process continues. Here's a PV diagram showing the exchange of energy. Energy flows into the gas during the expansion phase. Then, energy flows out of the gas during the compression phase.